All right, so 2 and 1, simplifying radicals, I guess part number 2. Now, if you haven't seen part number 1, I do highly recommend it because I will make kind of some assumptions here. So take a look at part number 1. So I'm going to put up a link up above. Now, one of the key things in simplifying radicals, sure, we can take all of these different, so for example, you have all of these different square roots. Notice I put up quite a few examples here. And then you even have radicals with third root, okay, so fourth root. Now, with all of these things, if you have a calculator, great, but what a calculator will do is it typically will just give you what the answer is, right? And then you don't really know what's happening. So I know that in, for example, in grade 9 or maybe in grade 10, you're going to get into simplifying these radicals. They're not really interested in what the final answer is because anybody can kind of punch it into a calculator and find out. But to try to understand the concepts with regards to simplification, and it has a lot to do with just factoring things out and then understanding what you can and what you cannot do. So before you tackle any simplifications, you have to, at least the tool that I utilize is prime factoring. You have to be able to take any composite number and then just prime factorize it. So if you don't remember that from elementary school, I will put up a link up above kind of on primes and prime factoring so you can refresh yourself there. But that's what I will be using for all of these examples. All right, so let's get started, and then hopefully when I'm doing these, you're going to learn on what to do. So here is example number 1. I'm going to kind of go through them one by one. So notice 18, okay, so I'm going to take the square root of 18. And in order to simplify this, I'm going to prime factorize 18 completely. So I know that 18 is equal to, so notice this is going to be 2 times 9, and then this is going to be equal to just 2 times 3 times 3, or simply 2 times 3 squared. So when you're trying to simplify now, because you have the radical, you're taking the square root. So notice that the 3 squared, well, the square root of 3 squared, so if you have this, that's just equal to 3. And therefore, so this entire thing is going to simplify. You can take the 3 and it goes in front of the radical sign, and then the 2 will just remain underneath. So your answer here is actually 3, and then the square root of 2. That's the simplified form of this particular example. All right, so that's example number 1. And I'm going to be using this pretty much for all of it. And you'll see that if you can prime factorize, then these things actually become relatively simple, right? So let me now remove all of this. I'll take a look at question number 2. So with 98, so again, I'm going to take 98 and I'm going to prime factorize it. It's kind of the first thing that I do. And in this case, so right away, so I'm going to say 2 times, and this is going to be 49. Now 49 is actually, so this is just 7 squared. So notice again, so right here, if you do that, then the 7 squared, so that's 7 squared, and the square root of 7 squared is 7. And the 2 will just simply remain underneath the radical sign. So this is going to be 7 and multiplied by the square root of 2. Now remember that what this means, it literally means 7 times, okay, the square root of 2. That's what it actually means, except we do not, okay, use this multiplication there. We just drop it. Okay, so that's what we have there. So that's example number 2. So let's take a look at example number 3, when you're probably going to start noticing kind of a pattern here. All right, so now example number 3. So if you take 75, so if you have 75, notice that 5 goes into 75. You can see that right away. And in this case, well, 5 times, it's going to be 15. You can check that. Now, you don't have to prime factorize it like this. You can start with something else. Notice that 3 also goes into 75, right? Because 7 plus 5 is 12, and then 12, okay, is divisible by 3. So that's, again, using just divisibility rules and then prime factoring. So in this case, we have 5 times, and then this is going to be 5 times 3. So again, so 5 squared, 3, and if you take the square root of that, well, that's going to be equal to, so this is 5, and then under the radical sign, we have the 3. And that's it, okay? So that would have been example number 3. So that's how you would simplify this. Okay, so here is another one, so 180. So now, so this is 2 times 90. All right, now breaking it down further, so this is going to be 2 times 45. So this is now 2 times 2 times, now 5 goes into that. So notice that's 5 times 9. So this is going to be 5 times 9. And notice, so here what you have 2 squared from here, multiplied by, now 9 is 3 squared, and this is going to be 5. All right, so this is what you have. And now if you take the square root of that, well, this right here, okay, because they're both squared, okay, so that's going to come out of the in front of the brackets, multiplied by 3 in front of the brackets, and then the 5 remains underneath. Now this right here, of course, 2 times 3 is just 6. So your answer here is going to be 6, and then you're going to have that. All right, and you can also check these for yourself. So for instance, and that's what I was referring to in part 1, okay, of the videos. So here, for example, notice that that 6 you can bring inside of the bracket, all right? And you will see that if you do that, so 6 squared is 36, 36 times 5 is 180, and you get your answer back. Okay, so you can always kind of double check back and forth if you're doing it correctly. So those are all various simplified radicals that we had. Now, what if you're going to start dealing with addition? So here, if you're going to be adding these things, so how do you do this? So typically, when you are going to start with these, you want to be able, because you can't just add underneath the radicals. You can't say 20 plus 45, which is 65. That doesn't work. All right, so what we try to do first is we try to simplify. So notice 20 is just 2 times 10, and this is 2 times 2, and multiplied by 5. So it's 2 squared times 5. All right, so that's your first one. So that's this. Now the 45, so if you're going to take 45, and you're going to prime factorize, so this is going to be 5 times 9, well, 9. So this is basically 3 squared times 5. So this is your second one. All right, so this is what you have there. So now with these two, okay, so so we have this one and we have this one. So if I simplify those, that 2 is going to come out in front. So you're going to have this. Then it's going to be plus. That 3 is again going to come out. All right, and you're going to have your 5. And notice now this doesn't always happen, but it can. Now you can actually add these because square root of 5 is a common factor. So this right here is just equal to 2 plus 3, which is 5. And that would have been your final answer. All right, so 5, let me get rid of this junk here. Delete. And that's going to be 5, and then square root of 5. And that's your answer. I mean, that's a nice simplified form that you have, which definitely looks much nicer. All right, so what about if you were multiplying, right? Like what about this one? So if you multiply, now I guess we have already done this. So this was, actually I forget. So this was 2 that, all right, so that's the first one, and then the second one was 3, so we've already done those in the previous example. So that's what this is saying, all right, so this is just saying this. So this is really interesting because notice that now you have, so what you can say is this is 2, so take all your whole numbers in this case, so 2 times 3, so 2 and then 3, because it's all multiplication, times this times this. All right, so that's what you have there. Now this right here, because you have the square root of 5 times the square root of 5, right? So this is nothing else but simply this, 5 times 5, which is 5 squared. So that is equal to 5. So that's great, because you have now 2 times 3, and then this just equals to 5. So 2 times 3 is 6, and 6 times 5 is 30. So your answer to this entire thing is basically 30. So now you've simplified that. Now another way, right, because obviously I used the results from the previous because I knew these two, but let's say if I didn't use the results, then what I would recommend that you do is you do the following. So you have that, and because it's multiplication, then this really just means this. All right? That's what that means. And now what you would do is you would simply, right, so 20 times 45, prime factorize that. So from here, so this is going to be, so this is 2 times 5, and this right here is, so that was 3 times 3 times 5, all right? And notice, so what you have, so with those, so I'm going to remove this. So what you have is, notice you have all pairs, so 2, 3s, and then you have your 5 times 5. So underneath this radical, you have this 2 squared, 3 squared, and 5 squared. And if that's the case, well, the square root of that is simply 2 times 3 times 5, which is 30. All right? So that's pretty neat, and that's what we do in these simplifications. So if you can prime factorize, it makes your life a lot easier. For those people who kind of struggle and start guessing, they will always struggle with these things. They won't know what to do. So the trick is to try to just catch on with the prime factoring, and then just use that, and then it just seems a lot simpler. All right? So now, what about, so this was the multiplication that I had. Now, what about the one below it, which is the division? All right, so this one right here. No different, all right? So what I recommend, again, so because you have the radical, so you can put it like this. And then what you do is you prime factorize. So we'll take the numerator here. This was 2 times 5 all over. And then here, this was 3 times 5. Once you do that, you're basically simplifying your fraction, right? 20 over 45 is a fraction. So you can reduce the fraction right away, right? So these 5s will cancel. And then all you have left, so notice you have 2 squared on top and 3 squared. And now you have this. So, well, what's the square root of that? Okay, so we know that this is just equal to 2. And this is equal to 3. So my answer here is just 2 over 3. That's it. That's what this is. And, you know, when you're doing these things, you want to be able to do it kind of on your own and check. Now, we can also, of course, I mean, let me pull up here. You know, you can kind of cheat and say, all right, well, this is square root of 20, and then what is it by divided, and then the square root of 45. Right? And then you can hit equals. Now notice it's 0.6666666, which is 2 over 3, right? Now, when you're doing it in class, I mean, if you were my student, I wouldn't really let you use a calculator because I would want you to be able to do these and understand what it is that you need to do. And then imagine that you were a programmer, right, down in the future, and you can program applications or whatever, software, to do these things because now you understand how it works. So, I mean, sure, you can use sometimes a calculator to just double check maybe your answers, but this is a great way in terms of prime factoring everything. So here's the next one, right? So it's the square root of 50 minus the square root of 75. So in this case, because I am subtracting, so I'm going to take So now the square root of 50. So let me prime factorize that. So that's going to be 2 times, right? So it's 2 times 25. And now 25 is just 5 squared. So that's the first one. The second one is 75. So that's going to be, well, 75. So I know that 5 goes into it, right? I think we did 75 somewhere here. Yeah, we have, so here's 75. Okay, but if you didn't do it before, you can still prime factorize. So you know that 5 goes into it, okay, so that's 5 times 15, and 15 is just 3 times 5. So this really is just 3 times, 5 squared, which is, so notice that now here, what you're going to get is this is going to be 5 square root of 2, and this is going to be 5 square root of 3, all right? And that, agrees with that as well. Now, with this case, so this is interesting, because can you actually subtract these two? Well, the answer is no, you cannot, because of the fact, now, of course, you can subtract them, but you can't say, for example, 5 minus 5, and it's going to be equal to 0. So the square root of 2 and then the square root of 3, are different. So the only thing that you can really do, you either could leave it like this, or you can take the 5 out, and it's going to be, that's going to be your answer, right? So you can do either this or either this, but that's as far as you can go. You can't do anything else. So with subtraction and addition, just be careful. All right? So that's another example. So all of these are kind of great examples that really force you to understand these simplifications. So now, so that's that one. All right, so we finished that. Now, what about this? So this is going to be the same thing. Now, I'm going to try to show you, so notice, because so far we've always done just the square root. And in school, typically you do a lot of square roots, and then you forget that these rules apply to higher roots as well. So cubed, fourth, fifth, and so on. Now, it's rare that a teacher may give you that, but you should understand that it means exactly the same thing. So let's break down 80 first. So 80 is equal to, so this is 2 times 40. This is 2 times 20. This is 2 times 2 times 2 times 10. All right, and this is going to be 2, times 2 times 2 times 2 times 5. So 1, 2, 3, 4. So basically what we have is 2 to the 4 multiplied by 5. All right? So that's what we have there. Now, when you're taking the square root of this, so sometimes when people, they don't see a 2 here, then they think, uh-oh. But do not forget, so what this means is, this simply means 2 squared times 2 squared, right, times the 5. And the square root of this, is just 2. So this right here, if you take the square root, this is square root of 2 to the 4, this is just equal to 2 squared. All right, so that's what it is, which is 4. And that's exactly what you get from here, because this is 2 times 2, which is 4. So my answer to this entire thing is basically 4. And then under the radical sign, I have a 5. So that's what you have there. Now, this is interesting because, so I'm going to, so let me kind of remove this thing. So my answer was, so 2 to the 4 multiplied by 5. Now I have a cubed. All right, so this is interesting. So what does that mean? Well, if you have this as a cube, you want to be able to somehow match it with this. So what I recommend is, so notice, this is the same thing as that, right? 2 to the 4 is the same thing as 2 to the 3 times 2 and then times 5. And now if you are taking the cubed root of that, so notice that first one, so this and this, right? So the answer of that, because 2 to the 3 is 8, and the cubed root of 8 is 2. So that's going to come out in front of your radical, and then everything else will remain. So that's going to be 2 times 5. So your simplified answer is 2, and then the cubed root, now 2 times 5 is just 10. All right, so that is your answer. That's how you would simplify this. So if it's a higher order than just a square root, you can still do exactly the same thing, right? If you understand these primes. So that, okay, in terms of this right here, so what I have there, because I have now the fourth root, so if I change this, let me change this to 4. Well, the fourth root of 2 to the 4 is just 2. And then under the bracket, under the radical, you're going to have your 5. So that's your answer here. All right. So now you've seen all of these different examples, and of course you should try it and try to understand it. The key thing is, can you prime factorize? So let's move on to the next one. So notice now I have this and I have addition. So I'm going to take that 54 and I'm going to simplify it. So 54, so I'm going to factor everything out. So this is going to be 2 times 27. Now 27, all right, is simply 2 times, so this is divisible by 3. So 3 times 9 and 3 times 9. So 9 is just 3 times 3. So notice that this, okay, so this 54 is 3 cubed times 2. That's that. Now 81, so if I take 81 and I prime factorize that, 81, 3 goes into it because 8 plus 1 is 9. So 3. 3 goes into it, actually it goes in 27 times. All right, so that, well, and 27, so notice 27 is, so 3 goes into that. So that's going to be the prime factorization. So this is really just 3 to the 4. All right. So far this is what I have. So I have 3. Now 3 to the 3 times 2 plus 3. Now because this is 3 cubed, I'm going to break down this 3 to the 4. I'm going to say this is 3 to the cubed times 3, right? So simplifying this is going to be 3 goes in front, cubed root, this is just 2 remains, plus, now in this case, the 3 goes in front again, cubed root, and then the 3 is underneath. And now I have simplified this. Now the question is, can I add this? And the answer, unfortunately, is, because this is cubed, this is cubed, that is fine. But your radicand here is 3, and here it's 2. So again, you're stuck. And that's as far as you can take it, unless you take the 3 and 3 out of here, and then you can rewrite it like this. But it won't really help you in any way. This will just depend. So you can, that's as far as you can take it, but these two are exactly the same. Okay? So that is another example. Here is a last one. All right, so last one in this huge video of examples, but the more examples, the better, because then you can see a lot of variety. Okay, so how would we tackle this one? So this is division, and then there's multiplication at the bottom, but you notice something interesting. So this is the third root, but this one that you have here, this is just the square root. So if that is the square root, right, it's different. So what I'm going to do is I'm going to do the following. I'm going to group these two guys together. So that is just simply the third root. So this is 405 all over 6. All right, so that goes together. Now the square root of 75 I cannot do anything with. So I'm going to do that. So now if I want to simplify this, again, just prime factoring. So I'm going to take 405, okay, over 6. All right, now 6 is just 2 times 3. All right, so that's not a big deal. Okay, so now the 405, so 3 goes into that, right? Because 4 plus 0 plus 5 is 9. So that's just prime factoring and divisibility. So we have, so this is 3 times, so notice the 3's will cancel there, but you have 3 times, and what is that going to be? So 405, let's see, 3, so 1, 3, 4, this is 0, so 3 and 10, that goes 3 times, so that's going to be a 9, 1, carry the 5, so that's 135. So we have 3 times 135 all over 2 times 3. Okay, so again, so this is just a fraction, so this is going to be gone. 2 does not go into 135. All right, so this is as far as I can take it with that. All right, now the 135, okay, so let's take a look, okay, and see what happens there. Okay, so in terms of the breakdown, so 135, okay, so to prime factorize that, I know 5 goes into that. How many times does 5 go into that? 17, is it? Okay, so let's take a look. So 5 goes into 135. 5 into 13 2 times. It's minus, that's 3, 5. And indeed, okay, so it's going to be 27 times. All right, so not 17. And 27, we know, so that's 3 times 3, right? So because it's 3 times 9. So that's interesting. All right, so what I have is here the following. Okay, so that 3, 405, all right, over 6. I'm working with that. Okay, so this is going to be, so that is 5 times 3 cubed. All right, so that's coming from there. All over, so let's not forget the 2. Okay, so this is what you have. Now, in order to simplify that, notice the 3 cubed. Okay, so that 3 can come out. So this is going to be 3. This is 3 up top there. That's going to be 5 over 2. So that's what you have there. And of course, we still have to simplify our 75. So now 75, maybe we did 75 already somewhere here. Oh, yes we did. So 75, there you go. So I can kind of cheat a little bit, but of course you would have to do it. So that was, sorry, that was 5. So that's going to be 5. All right, and that's what you have there. Okay. So now, can I simplify this any further? I mean, sure, I guess, you know, the 3 on top and then the square root of 3 at the bottom. So that can, you know, cancel out, okay, if you like. So you can leave it like this, probably is as far as you can kind of take it in some way, because of the fact that you have this right here. All right. So those are a lot of examples that you can try on your own, and some of them are hard. Most of the ones that you will do probably in high school are going to be kind of these upper ones, but then I really try to push it so that you understand and are comfortable with prime factoring. All right, thumbs up, okay? Hopefully you found it useful. We'll see you in a future video. Bye, everybody.